Hello, everyone. My name is... perfect. Okay, so I'm Paraskevas Bakopoulos, and I'm the director of NVIDIA's office in Athens. I suppose that you're everyone is generally familiar with NVIDIA, but I'd like to say a few words about our activities in the Athens office. So we started our activities back in 2017. Back then, we were part of Mellanox Technologies, and we joined NVIDIA in 2020 after the acquisition of Mellanox Technologies by NVIDIA. We are an R&D team. We have research activities that span a broad range from photonic integration to optical interconnects to data center networking and everything that lies in between. Today, the team counts 10 members. All of them are PhD holders. And our offices and our lab are in downtown Athens, so they are on Ermou Street. And of course, all our activities are aiming the end application of AI, as you would imagine. We live in the age of AI. It's not too long ago that we all experienced the iPhone moment of generative AI with the launch of ChatGPT. That became instantly a hit. So within the first 2 months, ChatGPT had reached 100 million users, and those users actually investigated and realized the potential of this new technology. So fast forward to, and started experimenting, of course. So fast forward to today, AI has become already pervasive across industries, and it's representing a thriving market that's reaching $300 billion by 2026. And to put that into perspective, the global supercomputing market is 30 times smaller than that. But it's not really the AI market that is important. What's really important is the transformative nature of artificial intelligence. AI improves productivity, and its impact on productivity, according to a recent research, AI's research impact on productivity can add up to $4.4 trillion annually to the global economy. And that represents an opportunity for the next industrial revolution. Let's go to the next one. All right. So in this new industrial revolution, the new factory is an AI factory. And the raw material is data. So data comes into the AI factory, it's processed, and it's refined, and the outcome, the product, is intelligence. So we manufacture intelligence in the form of digital tokens. And then this product, this intelligence, can be used in order to power new markets, new different applications, a lot of different applications. This AI factory is essentially an ensemble of tens of thousands of GPUs. Those GPUs are inter-networked. They are connected with each other with very high-speed networks, and they are orchestrated so that they can operate as a single brain, as a single GPU. So, and that's why we say that in this new paradigm of computing, the new unit of computing is the entire data center. Sorry. I think there's something wrong with this. Sorry for this. It looks like it has a very slow response. It's just skipping one slide. I don't know. Can you control it from your side? It should be a slide in between. Nope. All right. Let's. Perfect. Okay. Sorry for this. So I think it's a quite important slide because it shows that what I was saying is that we have this new computing paradigm, and in order to achieve this new computing concept, we really need to re-engineer everything. We need to re-engineer the full stack from the chips all the way up to the application optimization. And that slide actually, I insisted on showing this. It's because it shows the full stack. It shows how the full stack looks like. So we start from the bottom. We start with the chips, and the chips, the biggest chip is the GPU. We also use a CPU that's complementing the GPU for the operations that it cannot do. We have networking chips like data processing units, network adapters, and switches. And we have SoCs for specific applications, like we have the Jetson Nano, which is the smallest computer that we make, and it's used, for example, in drone applications. And then we get those chips and we build GPU servers. And then those GPU servers are networked using Ethernet or InfiniBand networks, and they build superpods. And which essentially are clusters of servers. And by adding more superpods, we can build a full AI factory. Now, on top of this hardware infrastructure, we have several management layers of software that abstract data movement and orchestration. We have toolkits and acceleration libraries. We have platforms that include APIs, SDKs, and services. And so that they can help developers integrate those new technologies. And on top, we have several application-specific or industry-specific applications. And we don't build those applications to compete with software partners. We actually build them in order to understand the pain points of those applications. So that's the full stack. NVIDIA is developing the full stack, and some customers prefer to get the full stack. Some customers prefer to get just the chips. So it's very flexible. In the next slides, I wanted to talk about, to give you some hints on NVIDIA's hardware and software design choices, if you like, and how those were taken in order to accelerate innovation and to help use AI in more and more applications. I'm starting with the hardware, and what I'm showing you here is what you see on the right-hand side. This is our latest GPU that is called Blackwell. That was released a few months ago, and we actually placed two of those large chips. Those are large reticle limited dies, and we place them, we assemble them on a common interposer, two of those together with a Grace CPU. And we have a very high-speed link between them so that they can operate as a single GPU. So that's what we call the GB200 super chip. I'm not sure if I can, yeah, that's the one. So these are the two GPUs, and this is the CPU. And we place 36 of those super chips inside a rack. This is what we call the GB200 NVL72 system. So that packs 72 of the latest GPUs, and they are interconnected. They are fully networked using a passive copper backplane that is shown here. And in order to scale to more GPUs, we use optical cabling so that we can go to longer distances, because that's not possible with copper. So what you see, I mean, the reason I'm describing this is to show the scale and the complexity of this kind of system. And looking at the scale and the complexity, it begs the question, how can we really scale to the numbers, to the volumes that are needed in order to build those AI factories that I was talking about earlier? How can we address all the diversified needs of the different users and the different use cases, given the engineering effort that is needed in order to build this? Because that requires tremendous engineering effort. You know, it has the latest compute, the latest networking, the latest optics, the latest cooling technologies. So, you know, it's really a challenge how to take such a complicated technology and use it in real life and in large volumes. So the solution to this is to use a modular reference architecture. So our approach to this is actually using a modular reference architecture that we call MGX. So this helps essentially by using an open source reference architecture. This helps OEM and ODM suppliers to design on this architecture, and that saves them tremendous amounts of engineering effort, and therefore it accelerates time to market and it improves ROI. And today, so the flexibility of this platform, so the modularity provides flexibility, right? So you can have different configurations of this platform in order to build servers that have different types of GPUs, different types of CPUs. They can use Gray CPUs, any different ARM-based or x86 GPU, and any networking DPUs. And that's how that's an overview of the building blocks of the MGX platform. I'm not going into much detail, but you can see that all different piece parts are specified, from the motherboard to the chassis, the power supplies, PCI base, cooling, and everything. And there is already a growing pool of vendors that are designing to this specification, and therefore they can improve the availability of this technology into a very broad market. So today it's available from more than 20 system partners, and there are already 150 different systems from different companies designed to the same specification. A few words also on the software aspect. NVIDIA's platform is designed in view of reliability and security for accelerating, for enabling users to adopt production AI. And it consists of four main layers. Starting from the bottom up, the first two, infrastructure optimization and cloud-native management and orchestration, are actually serving in order to make the infrastructure AI compatible. Then the third layer is AI and data science development and deployment tool. That's essentially all the required AI software tools for development and deployment. And on top, we have AI workflows, frameworks, and pre-trained models that help organizations get started very easily with their AI applications. So I'm going to give just a few examples on typical software, or important software that can help the easier use of generative AI. So the first one I wanted to talk about is NIM. NIM stands for NVIDIA Inference Microservice. And that's essentially a pre-trained AI model that is packaged in a container and is exposed as an API, so that developers can actually use it in order to introduce generative AI in their applications. And we work with the entire community in order to optimize their models, the available models, into high-performing NIMs. So we work with open source community models, with proprietary model developers, and with our own models. NVIDIA NeMo is used. It's an open. It's an end-to-end and cloud-native platform that helps building, customizing, and deploying generative AI models, so that take you all the way from the data preparation to training and to deployment of the AI model. And finally, well, sorry for this. It's another slide that is probably too heavy. Oh, yes. So finally, AI workflows. AI workflows are prepackaged reference designs that help organizations rapidly deploy end-to-end solutions. So organizations don't need to get into all of the hassle of the development of a workflow. They can use pre-trained, prepackaged reference designs for chatbots, for virtual assistants, for example, and a broad range of other workflows. All right, so I talked about the software and the hardware. The third pillar, of course, for innovation are the developers. And we put a lot of emphasis on supporting the developers with a number of programs and tools. And I wanted to talk about a few of those that I believe would be very relevant to this forum today. I'm starting with Inception. Inception is a program that helps startups across all the stages of their evolution. Inception moves across three different axes. The first one is innovation. It helps accelerate innovation by providing access to NVIDIA's Deep Learning Institute, and I will talk about the Deep Learning Institute later on, and other resources for startups. So you get lots of webinars and workshops and everything. The second axis is helping startups build solutions and get to the market faster. And Inception helps with this by providing access to SDKs, free cloud credits and discounts on hardware and software, and guidance on engineering. And the final direction, the final axis is grow. Inception helps grow your startup by providing more access to VC opportunities, to the VC community, and to other social amplification and PR templates. Inception is already a big project. It's a big program. It has already supported 20,000 of members, 20,000 of different startups across 100 countries and more, and it's growing. So I really urge you to go to the landing page and see how your startup can benefit from this program. NVIDIA Deep Learning Institute, I mentioned that earlier. It's a pool of resources for developers. It provides hands-on training on accelerated computing, AI, accelerated data science, and so on. So it includes workshops, courses, and it also provides certifications so that you can show your competency and demonstrate your competency and support your career growth by having those certifications. Let's see, next one. All right, too many. I think I skipped a couple of slides. Sorry about that. Oh. Sorry, that was probably too large of a file, too heavy. So sorry about that. Thank you very much. And so a few more programs. We don't see the actual slide. That's weird. Can you go to the next one, please? Apparently not. All right, that's it. Yes. Okay, so just a few more programs for educators. I believe that that's very relevant also for this forum. Targeting faculty and researchers. This program provides certification to teach workshops to students for free. And it also comes with material, teaching material, courseware, that includes resources, lecture materials, access to courses, and so on. And that's a more detailed list of what those teaching kits include. I'm not going through the whole list in the interest of time. And there are different course topics that are also listed here on accelerated computing, deep learning, accelerated data science, edge AI and robotics, graphics and simulation, and deep learning for science and engineering. Again, everything is on this landing page on the teaching kits. And finally, another tool for accelerating innovation in academia is the NVIDIA Academic Grant Program. There are regularly open new CFPs that are open on this. Currently, there are 5 CFPs open on the topics that you can see here on the screen. And I was actually looking for a good example to explain, how this program could look like. And I ran into a very recent program that was received by the National Technical University of Athens. This program was aiming at a tool to combat ocean pollution, and it used some donated RTX GPUs in order to do their work. So it's great to see that the Greek academic community is already becoming aware and making use of this opportunity. And with this, I'd like to thank you very much for your attention and for your patience.